tip is going to look at the function of bones. So there are several functions that we're going to look at. And the first one is support. So it's obvious that if we could take our skin and muscles and organs out, we would see our skeleton, and our skeleton provides the structure really for our body, both externally and internally. So imagine if you didn't have bones in your arms, you just have sort of muscly, floppy arms. And the bones of our limbs and pelvis and vertebrae give us this support. Protection, of course, what happens is there are a number of areas like our cranium, our thoracic cage, our ribs that protect our heart and lungs, our cranium's protecting our brain, our pelvic bones protect our reproductive organs to a certain point. So protection is another big one. Movement. Our bones serve as attachments for our muscles. Our muscles are attached onto our bones by a tendon. And sometimes when you eat a chicken wing, you can see that little sort of springy little piece there. That's the tendon that has attached the muscle onto that bone. And so because of this, our bones can act as levers to move body parts for us. So we certainly need that as we function throughout the day. Storage, we've talked already about storage, that our medullary cavities in our long bones stores fat. The bones generally are a storehouse for calcium and phosphorus. And it's very important that we keep a level of calcium in our blood because we need it for 4 important jobs there that I've listed: muscle contraction, nerve impulse conduction, blood clotting, and of course heart action. Heart is a muscle, smooth muscle, but it's got calcium has such an important function in it that I like to bring that one forward at this point. Blood cell formation. The term hematopoiesis, heme means blood, poiesis is developing of it. So it means all blood cells, hematopoiesis. Erythropoiesis would only mean red blood cells. These are two terms that students get confused sometimes. And that happens in the red bone marrow. And remember when we talked about this just a little bit earlier, we said it's primarily in the spongy bone in adults. In children, there may be still some red bone marrow in the long bones. But collectively what happens is our blood cells are formed here. Our red blood cells, white blood cells, and platelets are all formed there. Osteoblasts. Osteoblasts are cells that build, okay? Osteoclasts are cells that will erode bone, and serum calcium. So this is a really important concept to understand. Now I'm just going to go to the picture as we go through these few slides. This picture. So our osteoblasts, you recall, are bone-forming cells, and clasts are those that will dig it up. Now don't worry about this normal value here. Just know if it's up or down. That's all we really care about. When osteoblasts are developed from our connective tissue and they become active, and their job is to constantly be depositing intercellular material around them to eventually create osteocytes. Our bones are always remodeling inside, even as you're growing, even after you've done growing. And it's related to some things: how much calcium you have in your blood, or your serum calcium level. So when I say the word serum, I'm talking about blood calcium. And how much we pull on our bones, how much exercise do we use them for. If we become hypocalcemic, low, okay, low calcium, you can see here, that's what they're talking about. There are 2 hormones that we rely on, and we'll talk about those hormones more in depth in the endocrine system, but we stimulate the release of what we call PTH right here from the thyroid gland, the parathyroid gland. So PTH. And the function of that hormone then is to degrade some bone, right, or break down bone in order to put more calcium back into the blood for us, so our level will be status. So remember, it's always about a teeter-totter. So when the teeter-totter goes down like this, our calcium drops, we release parathyroid hormone and bring our calcium back up, so the teeter-totter would be balanced. And the opposite side, if we're hypercalcemic, so this would be hypocalcemic, that's referring to how much calcium is in our blood. So if we have a high calcium because we've drank a whole jug of chocolate milk, lots of cheese, so we're hypercalcemic. That's the level in our blood. Then what happens is we release a hormone calcitonin, okay, which tells us to deposit into the bone. So this would be osteoclast down here, and this is osteoblasts up here, and bring it back to a normal level. So this remodeling goes on throughout our whole life, and it's necessary, of course, to keep our skeleton in normal proportion. But usually what we'll see on a healthy, well person is our osteoblasts, or how we deposit, is equal to what we take out, or what the osteoclasts do. During exercise, our muscles then that are attached to our bone pull on that bone skin, or the periosteum, and that also stimulates osteoblast activity, which makes our bones thicker and denser by laying down new matrix. When osteoblasts are all done and they've got matrix all around them, then they're finally become an osteocyte.